Hi guys, I thought I'd do a quick video and show you something I've been working on. This is Cadillac Coupe de Ville, Sedan de Ville, rear wheel drive, front sump oil pump. And I need to build a motor that's going to take some power but uses this pan. And so what I've been working on is a girdle for the bottom end. And this is what I've come up with. And I'm calling it the Truss bridge girdle. Now, you can see with the front sump pan, there is not a lot of room at the front and rear main caps. And so even the regular halo, because remember, this is a halo, and I'll talk about it more in a minute, but the regular ones come all the way out, and there's not enough room in the pan for that to fit. So let's talk about first of why I'm doing this. Now, Courtney promised a guy he's going to build a turbocharged motor. We're actually building the motor, but he's adding turbos to it, and he needs it to fit the stock pan. And Courtney kind of promised him that he could do that. And it has now fallen to me to make it happen, and I got to get this motor built. So this is what I've come up with. Now, at about 600 horsepower, a Cadillac starts to have capwalk problems. When you get to 800 horsepower, it gets pretty severe, and you really got to start doing something about it. And of course, this guy with turbos has enough turbo to make more horsepower than the crankshaft will take. I mean, he's actually going to have to limit it. But I need this to hold up probably well into the 1,000 horsepower range with boost. The motor won't be that high horsepower naturally aspirated, but it's certainly going to be that or more boosted. So I've got to do my best to try and get the bottom end to hold up well, like Courtney promised. Now, the first thing you do when you start trying to reinforce a bottom end is called a cap strap, and that's what these are. And the reason for those is as you start to push harder with making more power, remember it tries to push the crank out the bottom end. So the main cap starts to cup, pulls in the side, it starts pulling up here, and we're just talking little bits, but then you start having trouble with main bearings. And so the cap strap is a bar that goes across the top of the cap to keep it from bowing. And even at 600 horsepower, you probably ought to be thinking about at least adding cap straps to a motor. Now, the halo is this part, and that's a whole different purpose. Now, what happens as you start going up is a different direction. Not just the bowing of the cap, but also partially because it tries to pull it in, but the cap starts walking back and forth. And so you need to try and tie the top of the cap together in order to keep that wobbling back and forth. And what you see is feathering in the cap to block joint. And like I said, at 800 horsepower, without something tying it together, that starts getting really bad. And we've tested it more than once. And so the goal here is to try and tie everything together so that you stop some of that wobble. Now, if you were only going to like 800 horsepower, you could probably just do cap straps and a center halo, and that would fit underneath a regular pan, and you'd be okay. But this is going higher than that, and so it needs to be a little bit better. Now, what I've done is we've welded another block on top of the halo, and that spaces this up, and I've brought a bar across that I've kept tight to the pan, and we're going to weld it to the cap straps. I'm going to slot it here, we're going to weld it to each of these bars that are on the halo, and we're going to weld it to the ends on the cap strap in order to try and act as a bridge and give us some more strength. Now, just like in a regular bridge that you drive over or walk over, the thickness here helps add some structure in order to try and give it some more strength. So these parts are not super thick, but it should behave itself like it's thicker than it really is. And part of my thinking on here is I could have just done a bar to here, but by carrying it to the center and welding here, that gives this bar some leverage, and so the only give is going to be some give in the material. And there's nothing I can do about that. That's as strong as it is. I mean, I could weld maybe a rib across the top here in order to try and strengthen it a little bit, but I'm not sure if that's starting to go overboard. And so you can let me know in the comments maybe what you think. If you look, I don't have room for a very big rib back here. There's just not a lot of room in the pan. And so it's only going to be so-so. But this should help out. And like I said, the more I can do, the better off I am. Now, if you look at this thing, it is really tight in a stock pan. Courtney promised a stock pan. I would have much rather modified a pan and gotten a little better girdle in here, but I'm working within the parameters that were promised to this guy. And so I have bent it to stay as tight to the pan as I can. I've had to trim down the cap strap in order to make more room and round the corner so that it doesn't hit the pan. And I'm still probably going to have to dimple just a little bit in order to get it to clear the bolt just a bit. I don't see a way around it. I don't want to make this thinner because I'm afraid we'll lose too much strength back here and it's not going to help. And like I said, I'm trying to work on strength this way. So it's trying to keep this from pulling. It's not about this way, which would cause this to bow. It's more about pulling it back and forth. And just really stabilization. So like I said, the more I can do, the better off I am. Now, part of the reason I have raised this up is, remember, you have a rod bolt in here. And Cadco has made these halos thicker before. They've made them 1 inch thick, and it didn't use the cap strap. But the problem with that is down here, you start hitting the rod bolt, and so you got to clearance the halo for the rod bolt. And so he went to this style in order to make it fit a little easier. And most of you guys, fitting the full halo in is a tight fit. But the centerpiece is at least some help. And like I said, even at 600, just putting on cap straps would be some help. And the halo is the next step up. And then this truss bridge is going to be a step beyond that. And then, of course, you've got the full 4-bolt main conversion that Cadco offers. But that's dry sump, special pan, all sorts of extra work. And this guy, of course, didn't want to do that at all. And so I'm trying to make this as strong as I can and fulfill what he wants. Now, my big worry is whether or not I've got clearance for the rod bolt back here. I have kept it as tight to the pan as I can, and hopefully I have room. I will not know until I actually go to assemble this. But my next step is to weld this bar. I'm going to put slots, and we're going to weld the bar into place, and then start prepping the block, and we'll have to assemble it and see where we're sitting, and see if the design is actually going to fit underneath the pan. I'll probably, like I said, have to at least massage the pan a little bit in the corners for the stud. And I've gone to a reduced head bolt. I've done everything I can to minimize what I have to do. And you can see, I mean, this thing just doesn't have a lot of room in order to fit it. But this is a built motor that it's going to go on. I mean, this is sitting on my welding block at the moment. But the motor is going to be built, good heads, and boost. And technically, he's capable of making more horsepower than the crankshaft will actually take. And so he's going to actually have to limit his horsepower in order to not break the crankshaft. And so this is what I've come up with. It's untested, but I am doing my best to make it as solid as I can and make it work for this guy. And if we like how it fits, I actually have a second build I need to do, and I'll probably have to make another one like it. But I'm really not going to know more until I get a little further along on the assembly of this motor and make sure that all my measurements and whatnot have worked and I can clear everything. So that's what I've been up to. I got to get this done and start assembling the motor. Mario has been busy prepping everything. He's got heads ready to go. And so if I can finish this up, we can knock the block out and we can actually start putting it together and see how well it fits. So I'll keep you posted. We will dyno this motor, but not with turbos. We are just building the motor. The guy is doing the turbo part himself. So we will break in the cam, dyno the motor, make sure everything seems okay, make sure we have good oil pressure and all that. And then it's up to the guy to hook it up. It's also going to be fuel injected, and so I'm going to have to rig a few things to dyno it with a carburetor. He's got a fuel injected modified intake that's going on this, and I've got to prep that a little bit too. It needs a bit of port work. So we've got some work to do, and I've got to get to it. So I will talk to you guys later and let you know how it goes. But this is what I've been working on, and I hope all your projects are going well. I will talk to you later. Bye.